This video is all about approximate change. So when we say change, it's either increase or decrease. So let's try to take a look of this example here. Given that y is equal to sine 3x, find the dy dx, hence find the approximate increase in y as x increases from pi over 9 to pi over 9 plus p, where p is small. So first, let's try to find that dy dx. So part number 1, part I, your y is equal to sine 3x. So you need your dy dx is equal to cosine 3x times the derivative of your 3x, which is 3. I'll just put that one in front. Alright, so this is now the answer for the part 1. Let's proceed to part 2. The part 2 says, find the approximate increase in y. When you look at the language of the question, the approximate increase in y is that delta y. Okay, again, the delta y is the approximate increase in y. Alright, while the delta x is the approximate. Sorry, let me just correct myself. Not approximate increase in y, but approximate change in y. And again, when we see change, it's either increase or decrease. But in this problem, it says increase. Alright? And the delta x is approximate change in x. Change in x. Now, let's try to look at the problem. According to this, the approximate change in y is equal to, or approximately equal to, the delta x times the derivative at x equals a, given that as long as the delta x is very small. So let's try to do it. It says the approximate change in y, or that increase, is equal to delta of x. So delta x times the dy dx at x equals your a. So you need to find first that delta x. What is that delta x? In the problem, it says it increases from pi over 9 to this one. So therefore, the x is increases from pi over 9 to pi over 9 plus p. So this is increasing to that. So therefore, the delta x is actually equal to p, because the second value is increased by p. So that is your delta x. Okay. Now, what is this one? It says the derivative at x equals a. So here, it started from pi over 9. So therefore, we need to find the dy dx at x is equal to pi over 9. So our dy dx a while ago is equal to 3 cosine 3x. You plug in that pi over 9 there, so you plug it in there. So therefore, you need to find the dy dx is equal to 3 cosine of 3 times pi over 9, which gives you 3 cosine of pi over 3. Alright? So, but the cosine of pi over 3 is equal to what? 3 times pi over 3 is 60 degrees. So the cosine of that is 1/2 times 1/2. So therefore, this is 3 over 2. Am I right? Yes. So you have there now. So now you found that dy dx at x equals pi over 9. So according to the theory, our approximate change in y, the delta y, is approximately equal to the delta x, which is equal to p, times the derivative at x equals pi over 9, which is 3 over 2, times 3 over 2. So therefore, it's equal to 3 over 2p. That's our answer. Again, it's very simple, alright? So the approximate change in y is only equal to the approximate change in x. So the x changes from pi over 9 to pi over 9 plus p. So therefore the change is p. Then you need to get the derivative of y at x equals a. So you found already the dy dx to be this one. If x equals pi over 9, you plug it in here. The cosine pi over 3 when you press into your calculator is equal to 1 over 2. So 3 times 1 over 2 is 3 over 2. Now, you can now plug it into our formula there, that the approximate change in y is equal to delta x. That delta x is your p. Alright? dy dx at x equals a. That a is that pi over 9 is 3 over 2. Therefore, our answer is 3 over 2 p. Right? Let's proceed to example number 2. Let's proceed to this example number 2. The variables x and y are related to the equation y equals 5x plus 2 minus 4e to the negative x. Find the dy dx. Hence, find the approximate change in y when x increases from 0 to p, where p is small. So, again, in this question, let's try to find first the derivative. So let's do the part 1. So the part 1 says your y is equal to 5x plus 2 minus 4e to the negative x. So let's try to find our dy dx. The dy dx, the derivative of 5x is 5. The derivative of 2 is 0. The derivative of negative 4e to the x is negative 4. E to the negative x times the derivative of negative x, which is negative of 1. So therefore, the dy dx now is equal to 5 minus 4 times minus 1 is plus 4 e to the negative x. So that is now our derivative. Let's proceed to the part 2 of the question. Part 2. It says, hence find the approximate change in y when x increases from 0 to p. So x increases from 0 to 0 plus p. So this is the change in x. Therefore, it means that your delta x is actually equal to your p. Okay? So now you found that delta x, what we need is to find this expression. The derivative at x equals a, but that is here, that's your 0, because from 0 to 0 plus p. So you need to find the dy dx, which is this. Okay? You need to find the dy dx at x equals 0. Okay, so the dy dx is equal to 5 plus 4 e raised to negative of your 0. Negative 0 is 0. E to the 0 is 1. So therefore, this is 5 plus 4 times 1, which is equal to 9. Alright, then we can now write the final answer. It says the approximate change in y is equal to approximate change in x, which is p, times the derivative at x equals 0, which is 9. So that's p times 9, or equal to 9p. That's the answer. Let's have example number 3. Example number 3. A curve has the equation y is equal to x cubed ln x cubed ln x. If it's not visible. Find part 1 is to find the expression for dy dx. Hence, calculate the value of ln x at the stationary point of the curve. Find the approximate increase in y as x increases from e to e plus p, where p is small. Alright, number 4 is not yet our topic. So let's do first the part 1, the dy dx. So the dy dx, as you can see, we have a product rule. So let's do the product rule here. So 3x squared u prime times ln x plus you copy your u, x cubed, then the derivative of ln x is 1 over x. So therefore you have there 3x squared ln x plus x squared. That is now your dy dx. So you have 2 marks for that. Let's proceed to the part 2. The part 2 says, calculate the value of ln x at the stationary point of the curve. When you say stationary point, it means that your derivative of x is equal to 0. So this is your derivative. So let's just make it equal to 0. 3x squared ln x plus x squared is equal to 0. Please take note that what are we looking for is the value of ln x. Please read the question very well. It's the value of ln x, not the value of your x. Sorry, it's not visible. The value of ln x, not the value of your x. So therefore, from here, we can see that we can factor out x squared. So x squared 3 ln x plus 1 is equal to 0. So again, what are we looking for is the value of ln x. So meaning, if this equal to 0, 3 ln x plus 1 equals 0, then 3 ln x is equal to negative 1. ln x is equal to negative 1 over 3. So this is the answer for the part number 2. So for the part number 3, it says, I will just write it there. So it says, find the approximate increase in y as x increases. So x increases from e to e plus p, where p is small. It means our delta x is equal to your p. So again, our formula was that the delta, the approximate change in y, is equal to the delta x times the dy dx at x is equal to a, in this case at x is equal to e. Okay, so our derivative a while ago is this. This is our derivative a while ago. We already got the delta x. Then we need to find the dy dx at x equals e. So the dy dx is equal to 3e squared times ln e plus e squared. ln e is equal to 1. So therefore, 3e squared plus e squared is equal to 4e squared. So this is now your derivative. So therefore, our final answer now is delta y is equal to p delta x times the derivative for e squared, which is equal to 4e squared p. So that is our final answer. Thank you very much.